All right, so today we're going to talk about exponential functions. And we're going to review your exponent rules. So these rules you got in Math 1. You went over them in Math 2. We're going to add a couple of things for this unit. So let's start out with a to the m times a to the n is a to the m plus n. And if you have a to the m raised to the n, that's a to the m times n. And if you have multiple things raised to a power, that makes a to the m p and b to the n p. Basically, you're distributing this power through to every base. Every base gets this power, and you distribute it to the exponents. Anything to the 0 power is 1. A negative power flips. So this is a flip rule. So the negative flips it to the denominator and makes 1 over a to the n. So over here, when it's negative, it flips it up and you get a to the n. And each of these, because this is negative, it flips down. Because this is negative, it flips up. And so you get b to the m over a to the n. When you have a fraction, a to the m over a to the n, this is subtracting a to the m minus n. And again, with the power on the outside, we're going to distribute it to everything inside. So we get a to the mp divided by b to the np. 1 to any power is 1. This may be new to you, this rule here, but we want to use this rule when we're solving equations. And this is something that you should have gotten in Math 3. So this might be review or might be new for you. If you have similar bases raised to a power, then those bases cancel out and you get m equals n. This fractional exponent here, if you have x to a fraction power, then the top power, the base becomes, the top becomes of the fraction, basically becomes the power, and the bottom becomes the index or the root, which is the number on the radical. And the base becomes the radicand. It's called the radicand. It's still the base, okay? If you have basic fractions, some basic fraction exponents, so if you have x to the 1/2, this is the square root of x, because this is like the same thing as x to the 1 and 2. The cubed root of x would be x, the cubed root of x, x to the 1/3. And the fourth root of x would be the fourth root of x. So if I had the square root of x, this is like 1, and it's the square root of x. So this is understood to be a 2 here. So we could write this as x to the 1/2, and the cubed root of x is x to the 1 over 3. So I could go either way on these. We've already talked about the exponential graph, that it crosses at 1. This is 1 here. That it swoops up. This is like our Nike swoop graph. And that, I said the Nike swoop graph. That's wrong. This is an exponential growth graph. And this is an exponential decay graph. And basically, this would be like y equals e to the x, or y equals e to the negative x. If the if the power was positive, it would grow. If the power was negative, it would fall. Now, a number that is probably new to you this year is this number e that I put here. E is a number, y'all. And so most exponential functions are in base e. And e is like pi. It's an irrational number. It's about 2.7182818282459 dot 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 dot. In your calculator to find it, you would use second ln. In Desmos, you just type the letter E and it knows that it's the number E, okay? So using these rules up here, we're going to simplify these down here. So using that first rule, when we multiply, the bases are the same. This would be m to the 4 plus 5 or m to the 9. When we're dividing, this is 6 minus 4 or k squared. So we can, when we do negative powers, I always say move the base where there's more of these. And I like to deal with negative exponents first, especially if I have to simplify first. So this would flip up and this would flip down. So this basically is x to the 6th divided by x to the 5th. Now this is something easier for me to deal with because I know I can just subtract these. And 6 minus 5 is 1 on top because there's more x's on top. So I get x to the 1 here, and I could just write that as x. This negative 3 means flip me down. So this gives me 1 over 3 cubed. I need this 1 as a placeholder because when I flip this 3 cubed to the denominator, I don't know what's in the denominator unless I put a 1 there on top. Now, this negative out here does not change anything because this is a power of 1. So this power of 1 says, leave me where I'm at. But this negative power says, flip me up. So this gives me negative 3a to the 5. Not negative bases, but negative powers flip. Okay, so be careful with that. Now over here, remember I said anything to the 0 power is 1. Well, this is the only thing that has a 0 power. So this becomes 1. So this is 1 times c to the 5 or just c to the 5. Number 7, this is like p to the 4 over 1. When you're multiplying, you go this way. So this is like p to the 4 over p. And this has a power of 1. Anytime it doesn't have a power, that's a 1 there. So 4 minus 1 is 3. There's more p's on top. Now, 5 has a power of 1, A has a power of 1, B has a power of 4, and C has a power of negative 2. Well, this power is positive, this power is positive, this power is positive, but this power is negative. So this is the only thing that has to be fixed because we don't want to have any negative exponents. So everything else is going to stay where it's at, and the C is going to flip to the denominator. Now, when we have multiple things going on here, we always need to do, just like order of operations, we need to do the exponents first. So remember I said we're going to distribute this power to everything inside. Well, what's the power on 8? Well, that power is 1. So we're going to distribute this 2 to both of these powers. So this gives me 8 squared d to the 6. Well, what's the power on this 2? Well, that's 1. We're going to distribute this 4 to both powers here. So this is times 2 to the 4 d to the 8. Now, we're not done with the problem until there's no variables that are the same. So I have d to the 6 here and d to the 8 here. Well, d to the 6 times d to the 8, that's that first rule. When they're multiplying, we add those powers. So that makes d to the 14. And I can take 8 squared and 2 to the 4th and put that in my calculator. And when I do that, I get something really big, which I don't have my calculator with me. So let's see. 64 times 16. And I'm struggling here to find, there it is. Is 1024. D to the 14. You could leave it like this if you wanted to, but I prefer it like this, okay? So again, we have negative 4 to the 1 power x cubed, y to the first, z to the negative 5. The only thing wrong with this is this negative power here, so we're going to flip it down. So we get negative 4x cubed y, and z flips to the denominator. Okay, so then we have to distribute this to here. We distribute it to here, but don't forget this 4. So this 4 is a power of 1, so we have to distribute it there too. So we get 4 cubed, x to the 15, y to the 33. You could leave it like this, but 4 cubed is 64, and it should be, that's a better answer, but either one of those would work. Okay, so what do we do here? So over here we do just, we multiply numbers times numbers, x's times x's, and y's times y's. So what's 4 times 7? Well, that's 28. And what is x squared times x cubed? Well, 2 plus 3 is 5. And what is y to the 4th times y to the negative 2? Well, 4 plus negative 2 is 2. And that would be your final answer. Okay? So same concept here. You would do numbers, variables, and exponent, and each one. But instead of multiplying, this bar means dividing. So 8 divided by 4 is 2. Now, when you're doing division, think about where there are more variables. So 5 and 2, we're doing the x's here, right? And there are more x's on the top up here. So I want my x's to be on the top. So 5 minus 2 is 3. On the y's, there are more y's on the bottom. So I'm going to subtract this way instead. I'm going to say 10 minus 7, and I'm going to put them on the bottom because that's where there are more of them. And 10 minus 7 is 3. And then with the w's, they're the same. 3 minus 3 is 0. Well, w to the 0 power is 1. So they cancel out. They go away. Okay? So that's your final answer. For number 14, there's multiple ways we could do this problem. We could multiply across and then divide. We could simplify this side, then multiply. There's like all kinds of things we could do here. I think the easiest way to do this one is to multiply across and then divide. So let's do that. So we would do the A and the A. So negative 1 plus 2 is 1. And the B and the B, so 2 plus 3 is 5. Then on the bottom, there's no extra A's, just that 1, right? And then 1 here, 1 plus negative 2 is negative 1. So now we would divide. So 1 minus 1 is 0. Well, that means they cancel out. And then here we get 5 minus negative 1. Well, that's 6. So we get b to the 6. Number 15, we would distribute this negative power through to everything, and then we would deal with the negatives. So we would get m to the negative 8, m to the negative 4, and p to the 12. So this would stay where it is because it's positive, but this would flip and this would flip. So this would give me m to the 8, n to the 4, p to the 12. But we don't know they're in the denominator unless we put a 1 on top. So this is our final answer here. So 18 divided by 78. This doesn't divide evenly. It comes out to a fraction. And so you want to leave it as a fraction. If you put it in your calculator, you would do math enter, enter. So 18 divided by 78. You would do math, enter in your calculator. In Desmos, let's see if I can get Desmos up on the screen here. I don't think you can see me on Desmos, so I'm going to go back. In Desmos, when you type it in Desmos, on the left-hand side, on left side of where you entered it, of the number, there's a fraction bar. It looks like this. If you click this, it turns it into a fraction. If it gave you a decimal. So this turns out to be 3 over 13. So I'm going to write that as a fraction. And then we're going to figure out where our variables go. So there are more x's on top. So 7 minus 2 is 5. And 3 minus negative 2 is 5 again. So y to the 5th. So last problem. This one's a little bit involved. So what I would do with this one, I would multiply across the top. I would distribute it on the bottom, and then I would divide. So 3 times 4 is 12. X to the 4th, that's a 1 power there. So x to the 5th, y to the negative 6. On the bottom, I have 2 to the 4, x to the 8, y to the 12. And 2 to the 4 is 16. So I'm going to go ahead and write that as 16 here. So 12 divided by 16 is a fraction again. That comes out to be 3/4. And then there are more x's in the denominator here. So that's where I want my x's to be. So 8 minus 5 is 3. There are more y's in the denominator here. So 12 minus negative 6 is 18. So y over 18. And so that would be your final answer. So just work them one rule at a time. Usually you start with the basic rules at the top and then work your way down, okay? And so that's all you would do in order to make these exponent rules